All right, welcome back to Mr. Slover's Math. Today we're focusing on graphing linear inequalities again, but this time we're focusing on special cases. So you're going to be able to graph a linear inequality. So here's our warm-up. This is just asking us to describe what we're going to do. It's not asking us to actually graph. It's asking us to decide whether it's dashed or solid, and if we're going to shade above or below. Just getting us in the mindset of graphing inequalities. So down here we have y is less than negative x plus 1. So we're going to have a dashed line because it just says less than, and our less than numbers are always going to be below that line. Same thing with b and c. Number 2 is asking to graph the following equations. Okay, so very similar to inequalities, but an equation, remember, is different. It does have an equal sign instead of an inequality symbol. So that's the big difference there. But when we talked about this unit, we saw x equals negative 3, so we just have x equals a constant, that means that we have a vertical line. And in this case, it's at negative 3 on the x-axis. So we have a vertical line. And over here, when we have y equals a constant, or just y equals a number, we have a horizontal line. So in this case, it's 6. So I put a point at 6, and I'm going left to right. So those two are just kind of a review for what we've done, but this is what we're getting into today with our special cases. So example 1 is asking you to state the slope and y-intercept fast, and then graph each inequality below. So I'm going to use this concept up here where I had x equals a constant was a vertical line. It's the same thing here. X and then some inequality symbol and a constant still means I have a vertical line. So I have a vertical line. My slope of any vertical line is undefined. So I'm going to go to 7. I'm going to put a point, and I'm going to go up and down. But I'm going to make a dotted line because it says x is less than 7. Okay, I'm not including anything on that line. I'm not including the 7. It's anything less than 7. So I'm going to think logical. If I have less than 7, that means it's going to be to the left of 7. So that's why I shaded everything over here. Okay, this is my solution set. Any ordered pair in here would make it a true statement. So if I picked 0, 0, and I substituted that in, I would get a true statement. Or 6, 7, the ordered pair, and I substitute it in, I get a true statement. That's what makes it a solution. Letter B. So now I have y is greater than negative 5. So I have a horizontal line, just like I had in the warm-up. My slope is 0, and my y-intercept is negative 5. So I didn't have a y-intercept on letter A because this vertical line did not cross the y-axis. That's why I didn't ask you to list a b value. But over here, this one does cross the y-axis. It crosses at negative 5. So I have a horizontal line at negative 5, which means it's going left to right. It says greater than, so that means it's dashed. And I'm looking for numbers that are greater than greater than negative 5. So anything in here is my solution set. Any ordered pair in here would make it a true statement. 4, 0, 4, 1, 8, 2, 8, negative 3. All of those are in my solution set in my shaded region. And then letter C is also a vertical line. Y is less than or equal to negative 1. So I have the equal to part in my inequality, which makes it a solid line. And then less than, once again, is below that line. So here's my solution set. Any ordered pair in here is going to make it a true statement. All right, on the back side, it says write an inequality that represents each graph. So I'm stair-stepping you into getting the actual inequality. I want you to identify the slope, the y-intercept, and then we combine it and put it into our y equals mx plus b form. So on my notes, I do have, on most of them, some arrows so you can see whether I went up, down, left, or right. I'm going from point to point, from point to point, from point to point. So that's what my arrows are telling me. So here I went down 1, which makes it negative, and right 1, which makes it positive 1. I crossed the y-axis at 1. So my slope is negative 1 over 1, or negative 1. My y-intercept is 1. I'm shading below that line, so I'm thinking logically. Would below be a greater than or a less than? Below would be a less than symbol. And since it's dashed, it's just less than. So here's my answer. Y is less than negative x plus 1, or y is less than negative 1x plus 1. Either one works. Let's jump down to, or let's just go to the next one. Letter B, I have my inequality here. Here's my shading. Okay, I went from here to here. I went up to right 1. So I'm going up to right 1. My slope is 2 over 1. Crosses at 6. And so my inequality, I'm shading below. So I'm going to have a less than, and it's actually a solid line. So this really should say y is less than or equal to 2x plus 6. And that would be my inequality. Last one I want to talk about is letter D. It is a vertical line, so that my slope is undefined. Anytime I have a vertical line, it's just x and then a constant. So since my numbers are all to the left of negative 1, I'm looking at smaller numbers. So x is less than negative 1. Anything in the shaded region is my solution. So today we focused on special cases. Graphing vertical and horizontal was the main focus, and then working backwards. So if you have questions, make sure you